just a couple things on the administrative side. I was very ambitious in my scope here. I would ask that folks save questions at the end. Normally I hate doing that. I prefer an interactive talk, but I have a lot to get through here, and I hope to cover at least most of it. Covering all 4 major clouds, we'll see how things go there. I want to talk a little bit about, like, what are cloud firewalls? Like, what does that mean? Well, it means a lot of things to different people. The way that I look at it is it's very specific in terms of it's typically either an appliance, like a Palo Alto, Fortinet, some kind of virtual machine appliance that you install in the cloud that looks somewhat familiar to what you do in data center. That's one form of cloud firewall. Another would be like a SaaS service. Some of the CSPs offer a SaaS service, either kind of internally or where that SaaS service is posted kind of off cloud in that vendor's own infrastructure. So those are the 2 cloud firewalls I'll be talking about. There's some things like WAF that I'll touch on as a firewall alternative, but like WAF and other things are not what I'm talking about here. It's mostly appliances and the CSP native cloud SaaSes. Just a brief couple points on firewalls and data center and campus, just to get folks a baseline on what things used to be like. In the data center, you had a very strong dichotomy between inside, outside interfaces, perimeter firewalls. You had zone-based firewalls where zones were collections of layer 3 interfaces. A lot of proprietary L2 mechanisms for state sharing between firewalls for HA. A lot of this stuff does not translate to the cloud. Whereas the configuration of an appliance, like Palo Alto, Fortinet, that part does translate. But the design piece, how do you inject those in a data path? That does not translate in the least. Oh, and then also on the orchestration piece, data center was typically a very manual, static way of deploying things because you're directly coupled to physical constructs, to big iron. Those things aren't the case in the cloud, so you have a lot more flexibility in terms of using tools like IAC to deploy clouds in the firewall. Now, a lot of folks, like say on the Twitterati, will argue that clouds in the firewall are an anti-pattern. We joke with our customers that the best firewall is no firewall. I strongly believe in that. If you can get away with other mechanisms like security groups, NSGs, NACLs, WAF, then you may not need a firewall. But that's just not an option for a lot of companies. A lot of companies have requirements for inspection of, let's say, outbound traffic or just general knowledge into the payload of packets, that firewalls are a requirement. It could be like a partner requirement. If you're a bank and you do business with certain partners, those partners may mandate that you need a firewall. A lot of the work we do where companies realize that they need firewalls, it's driven by some external thing, like an audit or third-party requirements, a partner requirement. Another one is partner VPN connectivity. Firewalls in the cloud make a great point to terminate IPsec VPNs. Just a natural point because you have tried and true software in the major vendors that can terminate IPsec tunnels. I want to talk briefly about the alternatives, just to help folks understand. NACL security groups, either stateless or stateful packet filters, depending on the CSP, applied to either the subnet level, load balancer level, virtual machine level, that are very basic. Depending on some applications, they may get the job done. They don't do any decryption. You're not going to know what's in that packet. But if you do these things right, then these may work out for you. And one example when I say do things right and do them vigorously, a lot of times in the cloud we'll see companies apply security group filters where they have a wide open on the egress. So those things, let's say a Ubuntu VM might only need to reach the Ubuntu mirrors for the packages download. Why would you open up complete outbound, all IPv4, IPv6 address space on the outbound? You don't need that. Then if those machines get compromised, they're going out and talking to whatever, and you have no visibility to that. Another sort of firewall alternative, even though it has firewall in the name, is the WAF. Most of the major CSPs do have a WAF service. WAF is a decent way to protect web apps if you have a web app. They block against very unsophisticated attacks. They're just kind of a nice to have thing to block against SQL injection and just known attacks. They're not going to be blocking against like 0-day type attacks. But they are good at what they do. They offer some very good kind of on the top benefits like being able to block geographies. If you know that you don't, if you're a US-based company, you probably don't want to communicate with overseas companies that are known to sponsor bad actors. Why would you allow that? They also give some pretty good visibility in terms of what's coming into your application. So I do like them in those respects. Oh, and also I want to mention third-party SaaS WAF, which we have had very good luck with. Companies like Cloudflare that serve as a WAF layer that can protect cloud presence, and they can also serve as like an intermediate layer to kind of route, like a big router that routes traffic either to cloud or a data center. So you can do some pretty cool things with routing traffic based on overflow, or if data center goes down, just reroute traffic to your clouds. We really like that design. Another firewall alternative is the explicit proxy. This is nice because you can kind of do it on any cloud. You have a proxy server. You have to configure all your clients to use that proxy server. You don't have to distribute certificates like you would for other outbound inspection mechanisms. So that's pretty nice. But then how do you keep that proxy highly available? That part can be a little bit tricky. Now, let's say you realize that your org needs cloud firewalls. Where do you get started? Well, this is a very daunting thing. There's a lot out there, a lot of ways of going to inserting firewalls in data path. It's not an intuitive thing. What I recommend is understand the taxonomy that I just referenced. Like you can have appliance virtual firewalls, you can have kind of SaaS-based firewall. If you know that taxonomy, that helps you kind of set your framework of thinking about what to do next. Understand those alternatives, security groups, NACLs, etc. Know what your options are, what tools are in your toolkit. Those are good things to know. Look at vendor reference material. I'm going to call out Palo Alto here because they do a great job documenting reference architectures across all the major clouds in depth. 60, 100-page PDFs where you can go through and see how those are done. Now, what's nice about those documents, it's not the Palo Alto way of doing things. A lot of what's in them are applicable to any virtual appliance firewall in the CSPs. You can take those same designs and plop in Fortinet, you pick, Checkpoint, it doesn't really matter. And I should also mention a lot of the designs I'll be talking about today are not vendor specific. There's nothing here that's vendor specific as far as virtual appliances. Fortinet, Checkpoint, whatever, these architectures will work in most cases. There are a couple of caveats that I'll mention as we move forward. Staffing knowledge considerations is a pretty important factor. If you know folks, if you have 100 people on your security team who know Palo Alto or Fortinet, you may want to lean towards, in your vendor bake-off, choosing that because the configuration piece is largely the same. The design piece is not, but the configuration of the firewall itself is going to be pretty similar, data center versus cloud. There's not a lot of differences there. Now, firewall integration, the cloud firewall appliances do have some nice integration features with overall cloud services. RCL is a big one, but I'm going to save that for a future slide because that's a big topic. Cloud tag awareness. And what this is there are plugins on the major firewalls where you can give them credentials for the CSP API and go out and pull tags and say, all right, what tags are out there? What tags are associated with VPCs? Now, why is that important? Well, you can use those tags to get addresses and populate dynamic address objects such that you can block, like I want ABCs with tags B, R, Q to be able to communicate, but these tags can't communicate. That's a pretty nice feature to have that kind of integration. The major players do have that integration. Cloud service awareness is another big one that is true to varying degrees for the SaaS offerings as well as the appliance offerings. Now, what is that? Well, since everything these days is HTTPS, like, what do you do? If the appliance is doing decryption and you can intelligently determine, like, is this object storage, S3 on AWS? Is this some other cloud service? Then you can make some pretty good decisions about whether to block or permit. A lot of the, I hate to say legacy firewall providers, but the traditional firewall appliance providers don't have that same degree of integration in their products that you see with some of the Cisco's and others through their Valtex acquisition to be able to say, all right, this is S3 traffic, or this is some other cloud service traffic. Auto-scaling is a pretty major integration point. As we all know, In the cloud, you don't scale vertically. You're not going out and buying a bigger pair of 2 firewalls when you need more capacity. You're typically scaling horizontally, where you're launching new firewalls, configuring them, and using some kind of load balancer to distribute traffic over the live firewall. That's a pretty important piece. You'll need a way to, well, I should say, that decision to launch a new firewall is typically based on some utilization metric, like number of sessions, various things, traffic. When you launch a new firewall, you need some way to automatically configure it. You don't want your staff at 3 o'clock in the morning to have to go in and configure a new firewall when your auto-scaling group launched it. So how that is done typically is the firewall goes out to something like object storage, downloads this config, typically with some kind of templating language, because you can't have the same config for multiple firewalls. And they're also going out and downloading the license, so that when they come up, they're fully licensed. You don't have operators who need to go in and configure those licenses as they come up. You don't want that. Now, we'll cover a little bit about firewall pricing and other costs. For the appliances, there are typically 2 models. Pay-as-you-go, which is the typical cloud on-demand pricing, where you pay by the minute. The price of the underlying instance is included, and also you're paying for the cost of the license. It's kind of embedded in that cost. The other model is called bring your own license, where you engage directly with the checkpoint, Fortinet, et cetera, buy a license, and then port it to the cloud. Bigger entities typically can negotiate good pricing. Almost all of our clients go the BYOL route and bring their own license into the cloud and use that license. It is a much better deal economically than paying on-demand pricing by a major amount. On the SaaS side, the SaaS firewalls, it's pretty much all on demand. Although I'm sure if you're a big enough org, you can engage directly with the CSP and negotiate better pricing. We don't have good visibility into that piece. Another aspect of firewall pricing is data transfer costs. The CSP always gets paid for data transfer. You can't really avoid that. So you're always going to be paying for that data transfer cost. I believe in some of the SaaS firewalls offerings, that cost may be embedded in the on-demand cost for the firewall itself. But just, you always have to keep in mind that data transfer cost, because you will get potentially burned there. All right, I'd recommend that companies consider deployment LOEs. The LOEs will differ based on that cloud model that you choose. If you choose some kind of SaaS, whether it's third-party SaaS, CSP native SaaS, it's typically a lot easier. You may not need the same levels of expertise to go out and get those into the data path. Now, if you do appliances, it's a lot harder. There's no real easy way to get firewalls inserted in that data path with appliances. The difficulty in getting them out there in terms of design is much harder. I want to mention some high-level considerations that you should think about when coming up with a design for getting your firewalls in the data path. There's actually a fairly few number of them that once you make those decisions, you can kind of get steered towards a certain design. Directionality is a big one. In a data center, we usually talk about north-south versus east-west. Well, in the cloud, it's a little bit different because we usually think about these designs in terms of outbound traffic originating in the cloud, going out to the internet, or maybe off cloud. Inbound traffic, cloud that's coming from the internet or off cloud, somewhere else, data center, into the cloud. And then east-west traffic. And just by how these designs typically look, you can often combine outbound east-west with inbound. Understanding your requirement for inspection is important there because there are different designs based on these different directionalities. An outbound design versus an east-west design versus an inbound design, those are different. So a lot today I'll be talking about inbound, outbound, east-west, so those are important things to be able to understand when you're selecting a design. Decryption requirements, your security message has to explain, do you need to decrypt traffic? Do you need to know what's in that payload? That often involves distributing certificates to your clients, trusted certificates, so that you don't cause a problem with the TLS connection, man-in-the-middle type detection. Now, another big one is, how do you draw traffic into the VPC? That's actually kind of a tricky thing. That's usually done with a public IP address, which might live on the firewall itself. It might live on a load balancer. you need some way to pull that traffic in. It's not quite like it is in data center. Level of orchestration, I mentioned sort of the deployment LOEs for the different models. And then operational familiarity. If you have a staff of 30 people who know Checkpoint, you may want to lean towards doing Checkpoint in the cloud. Even though things will be different, the actual configuration of that Checkpoint device will look fairly the same in most cases. When you're choosing a design, you're able to distill the number of kind of things to consider down to a relatively few number of things. And the answers to these questions will drive the selection of the design. Do you have a requirement for consistency across CSPs? We work with a lot of larger orgs who work in maybe 3 clouds. It's very important to them that the inspection architecture looks the same across all 3 major clouds. That is a vital thing for them. Now, what I always worry about when I hear that is, are you putting yourself in a position where you're choosing sort of lowest common denominator feature sets across those clouds to achieve that objective? I would hope that you can avoid that, but because the way that there's often centralized security teams, they don't want to have to manage 3 different design architectures across 3 different clouds. They want that consistency. It's very important to them. In the bake-offs that we've done, that factor has been weighted very highly. Is your app a web service or some other service? If it's a web app, you may make certain decisions. Maybe you don't even do a firewall, a traditional firewall, you just do a WAF. Or if it's a non-web app, you may make other decisions. Does your application need visibility into that source IP address for logging or for whatever reason? Now why I say that is, a lot of the architectures, there'll be an outer load balancer that's doing a source map. So you will not see that original IP packet. If you need that, and that is a requirement, that will drive you towards certain designs where either the source IP is in the IP frame itself, the packet header, it's in the XFF header, the exploded for header, or in a protocol called Proxy Protocol version 2, where it's another way of disseminating that source IP address all the way to the client. Firewall visibility to the payload, packet payload is a pretty important thing. If you are not decrypting traffic, what is the firewall really doing in that case? It's basically just making decisions on like layer 3 stuff. You're not really being able to take advantage of advanced features like Palo Alto's App ID if you're not doing that decryption. Now what's nice is some of the load balancers will do that decryption. You can terminate TLS on a load balancer, in which case it's doing all the work. You've offloaded all that TLS work onto the load balancer and you're getting that traffic unencrypted. Now, is that okay for you? We have customers who treat that VPC as a trusted entity where it's okay. We have customers who wouldn't think to have unencrypted traffic flowing across a VPC. Oh, I had mentioned that I'll probably use the term VPC to mean VPC, VCN, VNet, just too hard to say each time VPN, VCN. They're functionally the same. Virtual subnet data centers in the cloud. You can think of it that way. I'm going to cover degree of centralization next. A lot of companies want to centralize because they have one security team. That team wants to be able to dictate everything, goes in and out, security policies. That's very important to them. Now, when we talk about centralization, you have to be very specific, because does that mean you want to centralize, like have a choke point for all ingress egress off cloud, internet, whatever? Or do you just want to centralize the firewalls? Because in the cloud, those are different things. You could actually have local, to use AWS speak, IGWs in all your app VPCs, and then centralize firewalls on separate VPC. And through some techniques I'll get to later, you're centralizing firewalls, but you're not centralizing internet access. Some things to consider. Best practices. We recommend distinct firewalls for inbound versus outbound east-west. Now, why is that? When we first started in this, the vendors made this recommendation. I thought, wow, this is just a way for vendors to sell firewalls. But it's not. Once you get into the weeds operating these things, it actually makes a lot of sense to be able to scale outbound east-west and inbound differently, such that you can grow one pair and not grow the other pair. It works out pretty well, and we strongly recommend that companies do that. Employ automation for all plumbing. Some of these architectures have like 16, 17 route tables. You cannot configure this stuff manually. You will make mistakes. It's not Terraform confirmation. It's a nice to have. It is a must have if you're doing this, or you will be in some pain.
Do you feel strongly about that, Jeff?
I do. I've mentioned about in cloud horizontal scaling trumps vertical scaling. Typically, the horizontal scaling is going to use some kind of auto scaling tied to a load balancer. You definitely want to minimize any kind of per app, per VPC configuration. When a new app comes up, new VPC, if you can avoid having to do new firewall security rules, new simple firewall NAT rules each time, those would be the best way to go. I would also strive to avoid designs that depend on like quota increases. Like if you need a design that needs like 50 public IPs and the baseline quota is like 5, you can get more, I guess based on how big you are. I'm not comfortable with designs that do require on potentially ever increasing quota increases. Firewall H in the cloud. Data center proprietary L2 based mechanisms to state share between firewalls. I would argue in the cloud, you have to decide, do you really need state sharing? Do you really need existing sessions to be preserved? If it's a web app, the web client's going to retry. Some companies actually absolutely do need that state sharing. They cannot have existing sessions be torn down. But in a lot of cases, you may not need that. There are vendor proprietary HA mechanisms for the cloud. We've tested them all. They work to varying degrees, but we would strongly recommend not using those. And our clients tend to agree with this assessment. There are better ways to do things in the cloud, typically using load balancers. There is one architecture that's standard across all 4 clouds, so I'm going to dive into this one before we dive into cloud-specific, CSP-specific stuff. And that's what we call the sandwich model for inbound. I think it would help if I just showed a diagram while I'm talking through this. In a sandwich model, you have an outer load balancer as the upper piece of bread. You have a stack of firewalls, typically 2 or more, with or without auto scaling. And then you have an inner load balancer that directs traffic to the app, to the correct app VPC. These, like a lot of my diagrams assume that there's one app VPC per app. That tends to be the best way that we recommend going about things. Now, what the outer load balancer does is it tracks traffic into VPC, then it shoots traffic over a live firewall. It will not send traffic using its health check over a dead firewall. The firewall does a DNAT to the inner load balancer's FQDN, and then traffic gets distributed to the correct load balancer and then sent to the application. If you need standardization across CSPs for inbound, this is the only way to do it, the only way. Because of the different mechanisms, you cannot deviate here. All right, there's some considerations for the inbound sandwich. Firewall configurations can be complex because there's a lot of NATs involved, and they do require changes sometimes for each app. So if you're adding an app, you're adding more rules to the firewall. That's kind of a major negative point for this architecture. Demultiplexing apps can be tricky. If you have a lot of apps that use standard ports, how does the firewall know how to perform that DNAT, like which inner load balancer to send to? It's a hard thing if you're using standard ports. So what that drives is potentially is the use of one outer load balancer per application, which isn't a big deal, $35 a month. But I guess there's an operational cost to that in terms of now you're managing n number of load balancers instead of a single outer load balancer. All right, I'm going to dive into Azure. So basic outbound spectrum from Azure. Again, just want to remind, outbound means traffic originating in the cloud, container, VM, making a connection outbound to something. So the SYN flag is in that packet generated by the initial SYN flag, is in that packet generated by that thing that lives in the cloud. You could do something on Azure by directing a route in the private route table to the live firewall. But the big benefit here is there's no guarantee that firewall will be up. If it goes down, then you're having to manually, or through use of some glue logic like AWS Lambda or the equivalent on other clouds, the function as a service, to go in and make that change to the live firewall. or you're down for that outbound flow until that change is made. So there are definitely some drawbacks here. Now, on Azure, there is an internal load balancer that you can use as the next hop of traffic. So what you can do is you could have private route table point to that load balancer IP, which in turn directs over a live firewall. It's a pretty nice feature. Now you've solved that problem of not having this dead static route to a dead firewall. It's a pretty nice feature on the clouds that support it, and several clouds do support this internal load balancer. Now, I'm going to jump to east-west traffic, same VNet. Kind of the same thing here. You're inspecting traffic between these two subnets that I've depicted. If you want traffic to be inspected intra VPC, or in this case VNet, you can direct your next hop to that internal load balancer, live firewall. It's a very nice way of doing outbound connectivity. Now, you can extend this if you want your firewalls to protect n number of apps, and you want those apps to live in different VNets. What you can do is use VNet peering, point your next hop in the app VPCs to the load balancer IP, and again, that traffic gets distributed over a live firewall and then goes out to the internet. Pretty nice design. There are some limitations though for a number of VNet peering, the same way there are on other CSPs with VPC peering or VCN peering, things like that. So let's look at east-west traffic, different VNets. Kind of same thing here. You're pointing your next hop in different VNets to the internal load balancer IP, which directs traffic over a live firewall, then out to the internet. And guys, there are a lot of diagrams here, so I'll kind of be blasting through them. I think there's a lot of concepts here that I've kind of touched previously. I'll be focusing on the differences between like the previous thing that I've discussed.
And Jeff, if you're okay with it, we can make the slides available via Slack.
Yeah, definitely. Let's talk about the inbound sandwich architecture, same VNet. So you can extend this same VNet to include that internal load balancer, which again distributes traffic to a live firewall and then out to the internet. You can do that inbound sandwich architecture with different VNets using VNet peering. So in this, you have that outer load balancer. Also, I want to make sure that I kind of made that transition pretty fast. Inbound means traffic out there on the internet, maybe a user accessing a web service that lives inside your cloud presence. Same VNet, you can have that internal load balancer that distributes traffic to the appropriate virtual machine and container, what have you. Now, you can do the same thing with VNet peering. In this case, again, you have different app VPCs, one VNet, per app. Now, as with peering on other clouds, that peering is typically capped at some number, 125, just some number where that doesn't scale. If you have 100, 1,000 apps, which there are a lot of companies out there who do have an extreme number of VPCs, the ability to kind of move away from peering to some other mechanism holds a lot of value. There's just improved scaling properties when you rely on this virtual WAN hub. Virtual WAN hub, I'll make the analogy to transit gateway. It's kind of like that big router in the sky that can serve as a central aggregation point for app VPCs, for your security VPC that has the firewall. Now, one really nice thing about Azure, there's a SaaS offering that's powered by Palo Alto, and you can integrate that directly into the virtual WAN hub, their transit gateway-like concept. There's no equivalent functionality on, say, AWS. You can't tie a firewall to a transit gateway. Now, what I like about this, it uses this service insertion type mechanism to really easily direct that traffic to a firewall and then back out without having to do complex plumbing yourself. It's just like, hey, send these VPCs out to this firewall. These VPCs are trustworthy, we don't need to send those, but send these. We really like that about Azure, is the ability to kind of connect that firewall service to the virtual WAN hub. So if you add that virtual WAN hub, that kind of big router in the sky, you can see that in the middle of the diagram, that's a much more scalable option than VNet peering. It also is useful because you can make that same virtual net hub kind of an aggregation point for other stuff like VPNs, like off-cloud connectivity. So the fact that you can put a firewall directly attached to that is a very nice feature. All right, Azure has a native SaaS firewall service that's kind of separate from the Palo Alto SaaS firewall service. Not particularly featureful, mostly like a 1990 style feature set, pretty basic L3, L4 firewall. It can do some FQDN filtering for web traffic, for Azure SQL traffic. In its premium incarnation, it can do some IDS, IPS stuff, and it can do the decryption, TLS inspection. As a brief aside, we're finding that most of our clients do opt for that Palo Alto SaaS over the Azure native. For customers that have very kind of basic requirements, that Azure Network Firewall may do the trick, and if it works for them, then that's great. It's probably a simpler option. I should also mention that the Palo Alto SaaS, there's several options for management. You can manage it within the Azure console using sort of a dumbed down version of configuration, or you can manage it through your existing panorama. So you have the full availability of all the app ID and the fancy features that Palo Alto has. So this just kind of depicts that integration I referenced with the Azure Virtual WAN Hub, where you can directly tie that Azure Virtual WAN Hub to a firewall, either the Palo Alto SaaS or the Azure SaaS. Wired directly in, so you can use that to protect traffic, inspect traffic between VPN to cloud, internet to cloud. It's a pretty nice feature. All right, so Azure introduced what they called a gateway load balancer, which there are analogous constructs on some of the other clouds. Now what the Azure gateway load balancer does is it gives you the ability to associate a gateway load balancer to a VM NIC or a load balancer, whereas once you make that association, it uses not Geneva encapsulation, it uses a VXLAN encapsulation to send that traffic to some other place. So you're kind of creating this, like what we joke around about, is a magic tunnel to some other place where you can do that inspection. It's a nice feature. One thing we've noticed though is that none of the major vendor architectures use that in their reference architectures. We don't really know why that is. It does have some limitations. If you need some architectures that require centralization that we've tested, you can't use this Azure native load balancer. It does not have the same abilities in terms of variety of firewall inspection designs that, let's say, the gateway load balancer on AWS has. The way that it's built gives you much more granular abilities to make some different architectures. These things that you send that tunnel to could be some appliance from a major vendor, or you could roll your own. All you need to do is implement VXLAN. So you could just do some IP chains rules, set up VXLAN, and roll your own appliance. You can purchase these NVAs on the marketplace as well. This is a bump and a wire mechanism. I mentioned that it's tied to a load balancer or a NIC, VXLAN encapsulation. I've covered most of these topics. Skip to the next one. So let's look at firewall integration with the Azure load balancer. This is kind of how it looks conceptually. You make that association with the load balancer in this diagram, in this case, and it kind of goes off to this separate thing that's not tied with VNet peering. It's like a separate thing where you have your firewalls. It does the inspection, it makes that drop or pass decision, and then packets go back to that tunnel and then through your load balancer. It is a nice feature. We just don't see a lot of use of it. All right, I'm going to jump to OCI. I want to thank Daniel for some guides that he gave. He brought in some SMEs to help me with a couple of the more finer detailed points about OCI and how this cloud works. There are a lot of similarities with some of the OCI constructs with Azure, so I won't be going quite as in depth. I'll be covering kind of like how does OCI differ from the Azure piece, because of the number of similarities there. I'd be just covering some of the same things more than once. Okay, so basic outbound inspection. There is an internal load balancer on Azure. So if you have just a single VCN, your app lives in the VCN, you can point the private route tables next hop to the IP address of the internal load balancer, and that will distribute this outbound traffic over a live firewall out to the internet. So that is a nice feature that you don't see on, let's say, a cloud like AWS, where you can't set a next hop to a load balancer. There are internal load balancers, but you can't use them as a next hop in the routing table. Azure OCI does have that, so this makes a pretty nice design if you want to put all your apps in one VCN. We don't see a lot of that. We'd see mostly one app per VPC in most of the work that we do. You can do east-west traffic analysis in a very similar way. Same VNet, you want to inspect subnet to subnet traffic, shoot it through the firewall, you just set the route to the other subnet through that load balancer IP address. It distributes the traffic over a live firewall, goes back. Pretty easy way to do east-west inspection. Now, the dynamic routing gateway or OCI, roughly equivalent to a transit gateway to the Azure Inland Hub. It's not exact.
Very roughly.
Very rough. I agree with Daniel here. You can use that though in a similar way as that kind of a big router in the sky aggregation point. If you want to do app VPCs, one app per VCN, then you can set the private route table to point to that DRG, and the DRG can serve as an aggregation point, get traffic to the load balancer, the internal load balancer that puts the traffic over the live firewalls for outbound traffic. Similar, this actually goes back to, this should be VCN peering. There's a little typo there. If you have separate VPCs and you want to inspect traffic between those VCNs, you can route traffic through peering in this case. But for any kind of thing at scale, you probably want to move away from peering and go to the DRG. You can do sandwich like you can on all CSPs for inbound traffic. This looks the same as it does on Azure, on AWS. I'm not going to cover it again. I didn't see any major differences about how you would do sandwich architecture on that cloud. This is slightly modified for just using VCN peering. Same general concepts here. You can do inbound sandwich with DRG, where traffic hits that outer load balancer, goes to a live firewall, hits the DRG based on doing a DNAT to one of the application load balancers, the inner load balancers, where traffic gets distributed for the application. Now, OCI does have a network firewall. I have to admit that I'm not intimately familiar with it. From what I've learned about, though, it has some pretty impressive features. It does eliminate some of the more complex plumbing because you're not having to deal with that kind of load balancer firewall combination. You're just dealing with this highly available construct, native construct. That's from what I've experimented with, it's fairly easy to insert into the data path. Whereas it's a little harder when you're involving that internal load balancer and such. It's got stateful L3 filtering, URL FQN filtering, IPS IDS, TLS description. I noticed they can also inspect the VXLAN traffic, which I found pretty interesting. From what I can tell, it's mostly a drop-in replacement for some of the other designs I mentioned that involve virtual appliances. If you don't want to manage that virtual appliance, maybe you want to go with the OCI network firewall. It looks like a good feature. Okay, I'm going to bounce to AWS. AWS is probably the most longest running cloud. It's just halfway point.
5 minutes.
5 minutes. All right, I'm going to blast through this. AWS has the most features because of the way that it does gateway load balancer. Got a lot of options here. There's some features I'll just touch on briefly on how to get traffic into VPC. They added a feature called VPC ingress routing where you can kind of tie a route table to an IGW, which forces traffic into the VPC. More specific routes, so that you can direct traffic to a firewall's ENI. It used to be that you could not put a more specific route in a route table. bigger than the VPC side. Now you can. Gateway load balancer is the biggest one, and the way that it is implemented gives you a ton of flexibility with designs. This outbound inspection we've kind of seen on other clouds, no different, more or less. We've covered pretty much all of these about some of the drawbacks with outbound inspection. You could also use transit gateway. Our customers who do use the sandwich that we implemented prior to the introduction of gateway load balancer, they do something like this, where they have one app VPC per app, transit gateway. The problem here is still that if a firewall dies, you have no way of changing that static route short of this glue logic, like with an AWS Lambda to move to a live firewall. There's a slight change you can make by TGW's added a feature to do GRE tunnels recently, or not recently, but it's been out for a while, called Connect, where you can create a connect session to that firewall, run BGP on top. So now you solve that problem of not having to have a static route that points to a live firewall. Use BGP for that. It dynamically adjusts. All right, gateway load balancer. This is the big one for AWS. It uses Geneve, unlike VXLAN on Azure. Bumped on the wire. Since the firewall assertion is done via routing, the inspection is kind of all or nothing. You can't like selectively say, I want to look at this VPC or that VPC. It's kind of all or nothing. Integrates with auto scaling. You can roll your own appliance. You can buy one from the marketplace. It definitely simplifies configuration by eliminating NAT configuration on the firewall. So when you add an app, when you add a VPC, you typically don't have to make any changes on the firewall, because you have all traffic coming in that tunnel interface and going back out that same interface. In some designs, there are some exceptions there. So you don't have to make a per app change each time you add an app. Geneve header for reference. Just tunneling, say there's any other tunneling. So how do you do outbound with gateway load balancer? Let's say you have app VPCs. The gateway load balancer instantiates what are called endpoints in the app VPCs, and they create what we call like a magic tunnel, a magic two-way tunnel to get from app VPC to the inspection VPC. There's no transit gateway, there's no peering. It's just like this magical thing where packets go out, packets come back in. That makes the firewall management really, really easy. The configuration is much simpler. It's a really nice simple way. If you're doing this in AWS now, you definitely want to choose a gateway load balancer-based architecture. Don't do sandwich.
What kind of tunnel is that?
Geneve. All right, outbound east-west with gateway load balancer and transit gateway. Sort of similar thing, only in this case, the gateway load balancer endpoints live in that security VPC on the right side of the screen. Outbound traffic starts in the VPCs, goes to transit gateway, and goes out to that security VPC where it gets sent over the gateway load balancer and then out to the internet. Now, you have a decision to make here. This is an important one. Do you want that firewall to operate in one-armed or two-armed mode? Now, what does this mean? Well, the firewall could just do a routing decision and then send traffic out, which is nice because that gives you that same sort of thing that you're familiar with, where you have an inside interface and an outside interface. If you don't do that and you do one-armed mode, the traffic arrives on the same interface as it goes back out on that tunnel interface. So if you have people who know Palo Alto Fortinet, it's going to be very unfamiliar to them because it's the same interface going in and out. You can do some things like associate a VPC endpoint with sub-interfaces to give you back that ability to say, all right, this is my inside interface, this is my outside interface. There's some additional complexity there though. Outbound east-west with gets away, gateway load balancer, transit gateway. I'm going to skip this one. Oh, I went back to everything. Duplicated slides. Centralized firewall with distributed ingress. So, give me 1 second to adjust this slide, or to pull in this slide. Oh, in this case, this is what I mentioned where you can actually have a centralized firewall, but your ingress egress is not centralized. You can see here in this picture that the IGW lives in each app VPC. So, firewall centralized, the internet activity, internet is not. This is actually a nice design, it's simple. Some companies want this. Companies that need to have that centralized ingress egress point don't want to do this. Centralized firewall ingress egress for inbound traffic looks kind of similar. I'm not going to cover this one for inches of time. You can do the same thing, centralized, inbound centralized ingress egress with gateway load balancer. Traffic comes in to a gateway load balancer, hits the firewalls, hits an ALB, transit gateway out to the app VPCs. One thing I'll note, there's that pair on the app VPCs of ALB, NLB. The NLB exists just for that static IP address. There's no other function of that NLB, which you need because you need to direct traffic towards a static IP address. Oh, in this design, you could actually separate your firewall VPC from your ingress VPC. For diagrammic simplicity, I combine those. We do have a lot of clients who do want to separate that, so you have your egress VPC, or sorry, your ingress VPC and a separate firewall VPC. It's really up to you on what makes you more comfortable, more sense for your organization. AWS has a network firewall. It has some very basic L3, L4 features similar to the other CSP firewalls. It has some Suricata, the open source IDS, IPS integration. You can define your own rules. It has pluses and minuses. I find the Suricata syntax a little bit hard to parse. It may not be friendly for some organizations. You can do things like GeoIP blocking with Suricata rules. It's not native in the firewall. You can't say, I don't want traffic from these undesirable countries natively. You have to write your own Suricata rules. It's an unusual decision, in my opinion. The network firewall is a drop-in replacement for those other designs that I referenced with gateway load balancer. It kind of hides the gateway load balancer and has the firewall gateway load balancer as it's a single construct. You can use any of the AWS designs I've referenced. You can just use this in its place. One other thing that's kind of ancillary, I guess, is that the firewall rule evaluation on a network firewall is not what you all might be familiar with as network engineers. It is strange. That's very much an opinion. It's just not what you'd expect, and very hard to kind of get the rules that you want in place. GCP, I'll try to blast it really quickly. There's not a whole lot new here on top of Azure. There's an internal load balancer. So the designs here look pretty similar to Azure. The one major thing that I want to point out is that on GCP, VPCs are global in nature. So that kind of makes a different design decisions compared to the other clouds where VPCs, VNets are a regional construct. Also, I'm unaware of any network firewall on GCP. If they have one, I'm not aware of it. We don't do a lot of work on GCP. We've seen this before. I'm not going to cover this. This looks the same, internal load balancer, east-west, different VPCs. Nothing new here. All right, so I covered a lot of stuff there. I just want to kind of cover some overall themes I'll close out with. If you've been working in a data center, campus, enterprise, and you think you know firewalls, those skills may not carry over in terms of how you design the insertion into the data path. They will in terms of configuration on the firewall itself, but definitely not for how to get those into the path. That can be very complex. We see a lot of companies, typically smaller companies, they have maybe a 4 or 5 person design team, no security team. They're convinced that they can do it themselves. Now, we have the utmost respect for developers. I actually have some developer envy. I like what they do. We often have to come in after the fact and kind of clean things up because they realize it's kind of not in their comfort zone, and it's very hard for them. Because you've seen some of these diagrams. It's not something that you can quickly parse if you're not working in networking every day. I would argue that networkers can probably adjust more quickly to these things than a developer who's writing JavaScript or Golang all day long. These inspection designs are very complex. I mentioned that they can have like a ton of route tables. Imagine looking at like 17, 18 different route tables for some of these designs. It is just the cognitive load is a lot.
Is that a real number? Like you've had designs where you've had to deal with that many route tables?
Definitely. So automation is not just a nice to have, it's a must. You can't do this manually. You'll make mistakes. It'll be a mess. You need automation. For companies that desire a standardization, I understand what they're going for. I see why it's important, but it is a very, very hard thing to do. You're limited to things like sandwich architecture for inbound. You're not able to use some of those more advanced design patterns if standardization is your goal. We do see that a lot, though. It's really hard because you don't have those same constructs available across all four major clouds. I went really fast there through a ton of stuff. What questions can I field? Sorry, time
Let's
for
take 2 questions.
2 questions.
Very comprehensive.
Thank
Very
you.
comprehensive.
Thank you. Appreciate that.
So I was wondering if in your cloud gateway load balancers from an Azure point of view and AWS, have you done any benchmark testing about, performance-wise? I know there's overhead involved, right? One does VXLAN, the other one Geneve. There's different sizes, headers. Have you done any, performance testing, benchmark testing, and find, which one is better?
Our contributions to the bake-offs that we've been involved in are more around features, identifying caveats, gotchas. We're not doing any performance testing. There are typically other groups within our clients who are doing that piece. It's a hard thing in the cloud.
Yeah.
Spirent, those tools I find very hard to use in data center versus on-prem. They're different.
Yeah, I was just wondering, right, overhead, you have 64 byte versus 54.
Yeah, very true.
Yeah.
I don't know the answer.
Cool. No, great job.
Thank you.
You know what, I've always been curious, like, we do have our data center, we have a centralized firewall, like a firewall, show some inspection points. And, we hope that we can go towards east-west traffic. How can you do that? It's still using, because, we do have the call out, so it's nice to inspect the applications, all that. Is that possible, doing an east-west traffic?
Oh, yeah. Either same VPC or VPCN, or if you have one out VPC, you can do east-west traffic between VNets and VPCs.
Okay.
Using one of these designs.
Okay. And I'm just not familiar with that concept.
It's definitely an option. Now, some designs will rule out that east-west inspection, so you have to be careful about what design you choose. You want to choose one that supports east-west. Thank you.
I have a question.
Yeah.
What's the best way for people to follow up with you if they have more questions?
Talk to me after this. Definitely email. We're on LinkedIn. Be glad to talk to anyone about any more of this. We live this stuff every day. We love it. Love to talk.
You're on Slack, right?
I'm on the AutoCon Slack. Is there a different?
You're on NAV Slack. I don't know what else you're on, but you should all join the NAV Slack anyway. Thank you, John.
Were you saying the Slack for
Yeah.
USNA? I don't think I am. I'll have to join. But yeah,
sure you
once I
can.
do, yeah.
Your email address.
Jeff L at Konekti.us.
So let's hear for Jeff.
Yay!